Hi, my name's Michael Crawford. I'm your training instructor for this demonstration. Today we're going to cover getting started. So underneath the underlying application are folders and a folder structure. We're going to cover today application folder structures, library folder structures, model and drawing folder structures, automated file naming, and Weldment profiles. These are the fundamentals and the background behind how the Steel Designer Pro works. And I would assume that you have some knowledge of folder structures at this stage in your life. So there are some assumptions. So the first thing we're going to cover is the application structure. So the application structure is basically where the application is stored. So I'm just going to cover that in very easy detail. So if we open up Windows Explorer, go to C Drive, go to Program Files, CAD Craftsman, Steel Designer Pro. So this is where you're going to find the Steel Designer Pro application files for it to run. There are some significant files here that work on a regular basis. The first one is obviously when we install the software or when we update the software, we use these two files. One registers the software so that SolidWorks can see it, and the other one registers it so SolidWorks can see it. When we update the software, these two files are fired. Also, we have a folder structure in here as well. So you can see here we have Reeza3D folder structure, and this is where we have our templates for our Reeza3D. If we go back, we've got our reports. So this is our reports folder. So in each file here, there is information related to creating a report. We'll get into that a bit more when we cover our reports, but at this stage that's where they're kept. Also, there is a templates folder, and in the templates folder there is a Weldment profile template spreadsheet which we use for batch uploading your Weldment profile data to our Weldment profile database. We also keep inside this folder our standard help, which is linked inside SolidWorks. If you have an internet connection, it would automatically go to our help system within the web. If you don't have an internet connection, it will default to our help file here under English. Unfortunately, we only have English version at this stage. Later versions for different languages will come. Also, in the applications folder, there are our model templates. As you can see, we have several model templates. First of all, we have metric assembly and a metric part, an imperial part and an imperial assembly, and we also have a blank sheet template. These files here can be modified or updated for each version. More than likely we'll have them updated for you. They are used when we create new templates, so that when we kick off a new project or when we actually create new files such as an assembly, when we insert a new assembly or a new part. Obviously, depending on the units of the project, it will select which option, depending on whether it's an imperial or a metric project. So that pretty much covers application folder structure. Now we're going to cover the library folder structure, and the library folder structure is already built for us as we installed the software, and when we downloaded our library models, it also created those folders for us. Now these files are linked to a SQL database, so please do not modify or change any of these files manually, except for updating the current files already there. By adding new files will not be captured by the database if you just drag and drop the files into the library. There are only certain locations where you can do that without the library being affected in the database, and I will cover those in great detail. So first of all, let's open up our Explorer, and we go to C, and you'll see by default for all installations the Steel Designer Pro library is installed here. And depending on which country you have installed, in my case I'm in Australia, if you haven't picked up my English Australian accent, you'll see that I use Australian as a library. So inside of our library we have multiple different folders in place. My library is probably a little bit more extensive because I've got other things that I'm playing around with since I am the developer, but basically the folder structure that I'm going to cover is similar to what you will have anyway. So we go through the Australian library. So we've got basically our standard blocks. I've got a few more blocks in here. You can add any blocks you like, and this area is not affected or needs the database to be updated. What I do though is, because this is inside of a block system, inside SolidWorks we have a block area where you can drag and drop your blocks onto your drawing sheets, and that's what this blocks folder is for, just for storing all those blocks. This library location, however, is always on your local PC if you were working as a standalone. If you're not working as a standalone, you'll see a different folder structure. I'll cover that in the multi-user environment training video, but for now, being a standalone, this is where you will be. Going back to the blocks, we're going to now look at BOM templates. So just so you know that we use 4 different types of drawing types. They can be welded member drawings, general arrangement drawings, section drawings, and plate drawings. So each particular drawing may have a different BOM template for us to use. You can modify these BOM templates to suit yourself. However, I would use these as your default BOM templates. They are just tables. SolidWorks usually would you use a standard BOM template, but we don't use standard BOM templates. Maybe for your general arrangements you might, but we actually use tables, and tables are filled in with information. I'll get into that in more detail when we start looking at drawings and creating bills of materials. But for now, that's where our BOM templates are stored. So I just want to make sure and let you know that changing these could affect the outcome of you using or creating BOMs in your drawings. So be very careful about changing those. We also have drafting standards. Our drafting standards are a copy of, I would say, the ISO standard and then modified. Feel free to change these yourself. You can create multiple drafting standards and assign them to drawings using our batch drafting standard process, but by default most of our drawings are pretty simplified, such as weldment drafting standard might be the same for our sections and our vendor drawings. And our plate drafting standard is something that we use just simply for plates. Also, the welding drafting standard might also be used for doing general arrangements, but then up to you on how you want that. You might create your own welded drafting standard. Okay, so the next one's interfaces. I won't get into too much about interfaces. However, we have an application that allows you to create your own interfaces. We'll cover that later in a further down the track demonstration video. I also have a materials folder in here. You may put your materials in here as well. However, that's not linked to anything in our application. Maybe in future we potentially could set it up. At the moment, I've just put my Australian materials there, and as I add my materials that are not in the standard SolidWorks materials, I put them in there. Obviously models, I'll come back to models. Forget the P&ID symbols. That's something else we're working on in the future for P&IDs. We have a sheet templates folder. Now, these are our sheet templates, and you'll notice that we have some other bits and pieces in here as well as I play. I've got my assembly, drawing, and part templates in there as well. And then what I've done is I've linked the sheet templates to my default templates in my file locations inside SolidWorks to this folder so that I can select a drawing sheet and drop it in. At the moment, most of the time, they are just sheet templates. So you and your installation will have sheet template files in there. Now, why, you might ask, we have JPEG files of them? Well, it's simply because SolidWorks doesn't allow us to get a preview picture of them. So when we use the drawing sheet templates in creating a new project, it will find these files and it will upload them. And you'll notice that my sheet template has my company name inside of it. So you can grab our sheet templates and modify them and save over the top of them in here. And that way you've got your sheet templates. You can also put in other company sheet templates. Say for instance your business supplies a consultancy service in such that you may have many customers who want their own sheet templates. You can put them in here, and then when you create a new project you can select them and pretty much utilize those in your projects. This is where I put all my sheet templates when I'm working. When I set up a new project and I create a new project, these sheet templates get copied from this folder into the project folder and they get renamed. However, they are still the same sheet templates. The sheet templates in the batch drawing process, when you're creating drawings, will get swapped out from your library templates, because you may have library templates that don't have sheet templates that match your companies. When you go to create I shouldn't say when you create your drawings, but when you batch process your drawings, one of the features to be selected is to swap out the sheet templates to the project sheet templates. So that's the sheet templates. I'll cover that in a little bit more detail when we go to create a new project. Okay, next one is our Weldment profiles. Weldment profiles are very similar to the way that most people use Weldment profiles, except that we've picked up on the new technology where Weldment profiles can be configured. With that in mind, one single Weldment profile is used to be the process, so we would have several folders, and in those folders we would contain singular Weldment profiles. But now we have one file, and it's based on the type for that Weldment profile, and we will have many configurations of sections within that Weldment profile type. So we usually set these up for you automatically. I do advise that you do not use your own Weldment profile, so it's best that you use ours, and the reason for that is because our libraries are set up using our Weldment profiles, and when you go to change section sizes or swap sections out, we've got some nice little processes that allow the faces to stay put so that they don't fall off. Now if you put in your own sections and your own Weldment profiles, consider that SolidWorks with its Weldment profiles, every time you change a Weldment profile from another Weldment profile, you'll find that if they are different Weldment profiles, the edges have a unique identifier in the sketch, or should I say sketch segments have a unique identifier. And if that unique identifier is different to the unique identifier of the existing component, the extrusion process changes the face IDs. So then all your faces will drop. That's normally the process for using different Weldment profiles. So you'll see your connections will fall apart, and the reason that that happens is because the face has changed. You're using your Weldment profiles which are different to ours. We went down the path of using configured Weldment profiles, and the reason for that is because if you go to swap them out, you're going to get configured ones for ours, and you may have standalone single ones for yours. So basically the file structure for Weldment profiles is we start off with the standard. So if you're European, it'll be EN. If it's American, it'll be ISC, and CIC for Canadian, and so forth. Then we go down into the grade. Now the grade is something that we like to capture. However, in grade you might have the same Weldment profiles, but because it's got a different grade, the grade gets captured in your bill of materials. Now you'll find that with the Australian sections, if you're an Australian user, we've used our Australian standard call up for our grades. This is BHP rolled steel 300 plus, based on Australian standard 3679.1. Now in here you'll notice our Weldment profiles also have images. I will cover that in more detail later down the track in another demonstration video. Those images also are required for our application. So when we create a new section type for a particular Weldment profile, in this particular case it's a round bar, we've also created an image which is a flat image of that round bar. Now what this does is it allows us to add our own interface into SolidWorks and capture this image. Unfortunately, SolidWorks API does not allow us to capture previews of Weldment profiles, so we have to create our own images. So that pretty much covers Weldment profiles. Then we go over to the rest of the library. Now the rest of our library is covered inside our models folder. Inside of our models folder, everything that gets put into this, except for all the other folders that I've covered, and if I have forgotten to mention, I'm sorry, Those folders outside of the models folder doesn't require a database link, except for your Weldment profiles and models. Those two are important. Our Weldment profiles are uploaded to our database as well as what's inside of our models. You can add Weldment profiles manually to the Weldment profiles folder, but then you would have to collect the data and then add the data to the database. I will cover that later. For now, this is the folder structure for the models. Inside the models folder, we do not add or change any of the files or folder structures in this folder manually. We do not drag or drop any of the files out of here into any projects at all, because our processes are automated in this folder. It allows us to be able to insert models from our library using our SOLIDWORKS application, plus also using the SOLIDWORKS application, the Steel Designer Pro. We can add library models to these folders by uploading them, and through the process of adding them, it copies adding them to the library. It copies the existing model you may have open and puts them into the allocated folders that we specify to store it. Now, not only that, when we take files out of here, they are copied out of here using our application, the Steel Designer Pro, and they are inserted into your project, copied and inserted. So that means that the referencing back to the model library is broken. We never have references looking out of our projects back at our library. It's a fundamental feature that we've built into our application, which allows us to be able to copy a project from one location to the other and rebadge it in one of our features. Not only that, we've also got it so that whatever happens in the project stays in the project. Unlike SOLIDWORKS' recommendations that if you have a library model and you're going to reuse it over and over again, you would have everyone link that model into your project. We have also found that that process, albeit if it comes off your server, it's got to come across a network, it's got to be read across a network. And if your models are library models that have been imported, it can be very slow and it can slow down your model. This is another reason why we've gone to breaking your libraries away so that your projects stand alone. So also back to the file structure, you can see here basically we've got our connections, we have our parts, our projects, our weldments and our zones. At the moment, we don't have a feature for us to add in projects into the library so that we can use projects. We just simply copy our projects from previous projects. But you could, in the future, as we are working towards creating a library management process for us to install our projects into the library. But for now, connections, parts, weldments, and zones can be added to the library. If you go into the images folder, you can see that we have a number of images in here. These are images that can either be snapshots. Mine's a little bit more extensive because I've been working in here. I've been working on projects using the software. You won't get things like, chutes, bins, hoppers and things like that, because that's me modeling up concepts to put into projects. I've got a lot more conveyor stuff as well, conveyor models such as trestles and conveyor modules as well. We have gantries and all sorts of things that we've used for concepts to allow us to build projects very fast. If we scroll down, you can see we've got some driving sketch components. I'll get into that a little bit more down the track. You can see we've got our bolted connection images, and you'll notice that we also have plates and girts and purlins, and then we have our sections and also some other bits and pieces as they get added, including our vendor items. And you can see I've got bits and pieces of piping because we can do piping with Steel Designer Pro as well. So that covers pretty much what's in the library. As I said, mine's got a lot more in it than yours as far as the projects go. Now, if you want to create your own images, you can. You can open any image up after it's been added to the library. You can create a render using Photo3 View 60, set it up so that it's got a 200 by 200 bitmap as your output, and then you can open this up in something like Paint, and you can come along and you can add, just like this one. If I click add, you can see in Paint I've added the arrows. So you just click on the sketch type or add an arrow. You can do anything you like. Now what this does is this lets me be able to work out where the origin is for the connection, which items are selected as we insert the connections. I will get into that in more detail down the track. As you can see, it's a 200 by 200 bitmap. Now, before you do any snapshots or uploads, you might want to just switch your model over to have no background and make it no image, which makes it white. So when you bring it in, it comes in as a white object. However, I've done renders and it makes it look a lot nicer, and you'll even see that I haven't swapped my background out, and you can see that these are grey. So yeah, don't do as I say. Just take my advice. It works better for everyone if you actually do it in white and then come along and then add arrows. And yeah, do take my advice. Don't do what I do. Okay, go back to the models folder. Under here we've got our bolter connections. Now, our bolter connections folders that we see here off the top, these are called our library filters. I'll get into that in more detail down the track when we cover our library models, library management processes. But basically, these are filters that store our libraries, and when we insert them into our project, this name is in the file so that we know that it's a base plate or a brace plate connection or a cap plate connection. If you go down into the base connection, you can see we've got all the different base plates that are in here. This file name, being the folder, is the same as the images we were looking at before, and inside that we have all of our items that form that connection, including the drawings that are associated to the components that are in there. And we'll get into the file naming and what they're all about later in the series of training sessions. So that's our connections. We go over and have a look at our parts. So in our parts, we basically have a standard set of folders that have model filters that cannot be changed. These are fixed, and they are fixed for a certain reason. I'll cover that in more detail, but basically every file in here, as far as driving sketches are concerned, they're in there. So when you add a new driving sketches can be anything. They are usually our main core item that everything is attached to, that allows us to make changes to very quickly by double clicking on a dimension and then having it automatically parametrically move. I'll get into that in more detail as we go further down into driving sketches. Our fasteners, at the moment we've just got a couple of fasteners that we've got in our library. I've got one here that I've added in later. You can add as many fasteners as you like. I do recommend that you maintain the fastener model that we have because it's been modeled a certain way, and change it to suit your needs or create new ones from it. Insert it into your project, open it up, make changes to it, and then add it back into the library by using our library manager. We also have grids for grid balloons on 3D models. We also have levels, so we can insert our levels into our 3D models. We have plates along with their detailed drawings, so you can see here on the right hand side as I click through, you can see each one of these plates has a drawing that's detailed behind. Okay, so we've got lots of different plates in the library that you can catch and put into your project. We also have a sections library, parts library set up so that when you do put a section in, the drawing comes along with it as well. As you can see, I've got different types of sections in here, and these are all linked to a database to allow us to search for and automatically insert. Rather than inserting a welded member from scratch, sometimes it's beneficial for us to be able to just go straight through, select a section, and then insert it. And when we insert our library model, so does the drawing come along as well. We also have a vendors folder. Now, vendors items are treated differently to sections and plates. I'll get into that in more detail, but basically vendor items can be items that are bought off the shelf via a third-party supplier. They can be anything from, as you can see, reinforcement there, beams, sections, cuts, couplings, and you can see grating and mesh, gaskets, and all sorts of things. So you can create any kind of vendor item you like and store that into the library as well. Okay, so that pretty much covers the library location for a standalone user. Okay, now being a standalone user, like I mentioned before, they have a different library location to a multi-user library location. Now, multi-user library location and a shared library location are under a different folder. I'll cover that in another topic for multi-user environment. That pretty much covers the library folder structure. Okay, so now we're going to get into modeling and drawing folder structures. So now we're going to cover modeling and drawing folder structures. The first thing that you need to know is that basically the interface that pops up at the beginning is our project command center. That allows us to go straight into project zones. It also allows us to go down into projects and open up projects. If we double click on a row, it allows us to access the data of the project and update the data after we've created a new project. We can open up a project assembly or a zone assembly. Now, the filing system, as you can see over here on the right hand side, we've got a shortcut to the filing system that comes up. And at the very bottom page, you can copy the shortcut and paste it into a Google page or your web browser, and that will take you to our filing system. I'm going to cover this in great detail because it's all automated. It means that when you take something out of your library and you put it into your project, it's all filed under this system, so you know exactly where to go and where to insert things. So basically, let's start at the top. The project assembly, the very top one, is for massive projects. It's for projects where you've got multiple people working on different zones, which is the zone assemblies below, so that they don't step on each other's toes while they're working on the same project. So for instance, you can see here there's an image of it's a manganese plant, and in there we've got a primary crushing station, we have a transfer conveyor, and there's a screening station and a stockpile and so forth. Now, you might have one person working on a primary crushing station, you want one person working on the conveyor, and if you put everyone in the same assembly, it's not going to work out very well because you're going to be trying to juggle models in the same project, because in SolidWorks you cannot open the same assembly up and work on the same assembly. So if someone has the assembly, you don't want that assembly well, you can't have that assembly open by someone else. I mean, it's quite simple, really. What that also means is that because of that being the case, you need to create a system whereby multiple people can work on the same project. Now, if you're working on a project team, there's 20 of you, the last thing you want is everyone stumbling over the top of each other in the same assembly. So what we've got is this project assembly. Now, the project assembly is just particularly for those really large projects. But all the magic happens down here in the zone assemblies. Our zone assemblies are here for a reason, and that's where we work on all of our projects if you are a single user. A single user being someone that's going to start the project and finish the project all by themselves, or they may start the project, get tied up on another project, and then hand it over to someone else to continue on. It means it's only a singular person working on that project. However, you can have multiple people working on a zone assembly, but they need to work on welded member assemblies down below. Okay, consider that you can do that, but you have to deal with it a certain way. Now, if you're on a standalone license is just that. It means that you're standalone. You're alone. No one else can work on your project. The project's stored on your C drive. Okay, now we use the C drive to store our projects and to store our libraries as a standalone for the very reason that we use solid state drives. Solid state drives allows us to get maximum performance, and we get maximum performance by storing all of our models on that drive. Now, there are some fallbacks associated to that. Obviously, backing up needs to be set up a certain way so that you can back up your projects so that your projects are captured. Some people can work in Dropbox folders, they can work in Google Chrome, Google Drive, or in OneDrive. So that way they are getting backed up every time you're working on them. That's one way of doing it. Another way of doing it is that you can use a replication application that allows you to, every change in 5 minutes, copy the files across onto your server. So that way everyone's got the latest files on the server, no matter what happens. That's another really good application that works quite nicely. There are free versions such as Free FileSync that will allow you to be able to do that. But I find Dropbox to work better because you've got version control, whereas Free FileSync doesn't have the version control process. Now, this is for a standalone. For our multi-user environment, you can check your files into the server, you can check them in and check them out. Very similar to the way that SolidWorks' PDM works, except that we're not as powerful. We don't have version control. If you use that application, there is no version control. However, you can manage multiple users working on the same application, or sorry, same project, without stepping on each other's toes. That can work where maybe at the project level assembly, someone's working on a particular area or a particular zone within that assembly at the top level, and then someone down below is working on another zone assembly while someone's already got the top level project assembly checked out. So you can check out files up and down the tree level without stepping on each other. And not only that, our multi-user environment will allow you to share your libraries. We've also got in our professional edition library sharing methodology is there in there as well, so that you can set up one library on a network. However, those files are on the network server, and they will be copied down when you go to select them into a temporary location on your C drive for insertion, because it doesn't insert them straight from your network. So the zone assemblies are basically where all of our welded member assemblies are inserted. We do not insert welded members into project level assembly. They go into the zone assembly, and that's where they go, and that's where they stay, and that's where they reside. Inside of our welded member assemblies, we can contain sections, plates, and vendor items. There are our three models. We can main models, and then we've got fasteners, we've got driving sketches. All those items can be stored inside our welded member assembly. Also, those items can be stored inside of our zone assembly. So just be wary that you can insert those library items into any of those levels. Also, they can also be inserted in at the project level assembly as components as well. You can't do it with welded members at that level, but you can put welded members in at zone assemblies. All components can be inserted at zone and project level and welded member and bolted connection levels. Now, parts such as sections, plates, fasteners, even holes are components, because we use holes to create cavities to manage our parametric hole creation tool, so that if you modify holes in a plate, the holes automatically update in any matching sections. So that pretty much covers our folder structure for a project. Now I'm going to open up a project and I'm going to show you how this file structure works, so that you can see basically from this overview how it's all automated, because everything's automated from here. If we go to our project command center, you can collect it by right mouse clicking up the top here and turning it on, or you can go into the menus and grab it from the Steel Designer Pro Project Command Center. When you open this up, you can go into a project that's already created. We will create a project in the next video, but I'm just going to show you how the file system works. So at the moment I've got a couple of projects in here. I'll pick a small project we've been playing around with, and you can see how the projects are formed. So in this case I've got one project and I've got 4 zones in the project. So if I was to open up the project level and go open project, this will take us via configuration to the project and open it up. Similarly, to open up a project, you can use SolidWorks to open up a project, but it doesn't set the project number when it logs it in our features, so that when we're using the features, it can collect it. But it's best that you use our tool to open them up. Now, if you've actually used our tool to open up a model and then you've got out of it, and then you go to open up SolidWorks, you can open that model up because the project number has been stored. Now, this is me playing around. You can see the folder structure off to the left hand side here. We've got assemblies, and we've also got 2 plates inside of our project level assembly, which you can do. Okay. Now, you'll see here there are 2 lots of plates here. This is me playing around with sticking plates at zone levels and sticking plates at assembly levels. And then you'll see in here we have zones. We have a couple of zones that have been inserted into our project level assembly over the top of one another. If I open up the folder structure for this project, you can see here that our tutorials, I've got the project here, and then inside that we've got all of our automated filing system built in. Okay, some of them aren't, so these shouldn't be there. So we've got good, that's me playing and testing. We've got plate DXFs, so if I've created any plate DXFs within the project, they get stored in here. If I have any deleted files that I've deleted using the delete process, it gets stored in here as a backup, so I can always come back and get it if I need to put it back in. All of our DST files are exported and folder structures automatically created for the project. All of our PDFs are stored in the PDF folder. All of our plate DXFs are stored in the folder, and you'll also see our sheet templates. Now, our sheet templates are copied, like I mentioned before, copied from the folder in our library and put into our project's sheet templates folder, and these are those files, and they are renamed. Okay, now in each one of these we have our zone folders, and you'll see that our zone folders start off with the project number to keep the consistency going, and then they go into the zone code that we've specified for that zone. And inside that we have our welded members, and you can see we've got beams as a welded member, and then when I pull that back you can see I've got a beam that I've dropped in from the library. I shouldn't say dropped in, I've inserted, because it copies them, it inserts them. When it copies them and inserts them, it brings across the drawings as well, and you can also see even the columns have been inserted from the library as well. Also in that folder is our zone assembly, so that's our zone assembly, and anything that's been inserted at this level inside this model at the zone assembly are the files that have been inserted. The same thing applies for project level. You can see in the project level on the left hand side here in the feature tree of SolidWorks we've got two plates. You can see there's the plate and the plate drawing at that level for the project, because that's where they were inserted. So the tree structure is fully automated, so when you insert something from a library at a particular level, it will store them in that location for you. Usually plates, sections and vendor items, or grids, or reduced levels, or fasteners are single file only items, which means it doesn't require a folder. So the more items we stick in at this level, the larger this folder will become. If we go down into the welded member level, you'll see when we insert a welded member is usually comprised of multiple items. So taking in, for instance, that's not a very good example actually, our hand railing might have many components. That looks like that's a new handrail that's been inserted that has not been completed. If we go into columns, you can see in the column we've got a part, which is a section, and we also have a welded member which contains that part, and that creates the column. So the folder for welded members is inserted from the library along with all its containing folders. Now there are no connections in our column here, but one of our columns has a connection, so I'm just going to drill down and see if I can find it, and not in this project. So to find out where our connections are, if we go down and look at this section, we can click on it, and you can see that in Tute 3, as you go down the structure, you can see Tute 3 is the project in the feature tree. Sorry, you can go down the tree structure, you can see Tute 3, L2 is the zone, and then there's a column L2, right, and that's where that connection should reside. But you can see that I've actually got zone 2 sitting over the top of another welded member zone, another zone assembly. So I've got two zone assemblies on top of one another. So when we click on this sketch, you can see down in here we actually have a connect. So when we click on this face and we click on the column, we can see that down in here there is actually a connection. So if we were to open up the column welded member, you can see it's a welded member, which means that it's got a base plate that's welded to it. That's why it's called a welded member. Anything that is welded together is a welded member level assembly. So inside of our welded member assembly, we open up the folder. You can see in here there's another folder, and that folder is our connections folder. So even connections come in a folder like welded members as well, and that folder contains all the items that are associated to a welded member, including in this case base plate bolts, base plate, and the sections that form that connection. So that's a welded member assembly. Connection assembly is the lowest form of assembly structure that you can see. So if we go down into Tute 3 level 5 using our file system, so let's go into that manually. So I know where my project is. My project is stored here because I've set it up. under tutorials, tutorial 3, and then level 5, and in here this is where the column is, right? But the column is column 1. So you can see here we've got the folder structure. Now you can see that just by getting to that point there, that is the maximum folder structure that we have. The largest file structure or file length, when we pull this back, you can see here in this particular case is more likely the fastener's name. So if you tack that onto the end of the folder structure, you can start seeing that our file structure gets quite large. It is recommended that you go no further than 2 levels in storing your projects. Preferably, myself, in my projects, because this is a tutorial and it's under Steel Designer Pro, I would prefer to go C, projects, and then put my projects in there, and that way I only have to deal with one folder. The longer these are, the longer it takes SolidWorks to find the files, because it's got to extract this information in all of its references. It can slow down your project's rebuild and loading times. My catch is just trying to reduce this as much as possible. Now we're all moving over to SolidWorks 2020 soon. SolidWorks is going to force you, unfortunately, to upgrade to Windows 10. Windows 10 has a function or a feature, a setting in the registry that allows you to be able to make your file systems longer than 256. 256, I think it is the maximum characters you can have in the length of a folder, and I should say a file, because what will happen is you'll end up with some problems. You won't be able to copy the file. It won't let you in Windows copy the file. You actually have to use DOS, and that causes problems. But with Windows 10, you can go in and you can make it so that it's unlimited. It's not recommended that you do that, but when you're storing models in zones in your library can have a really long file length and folder length. So just be mindful that sometimes you might need to turn that on, and if you need to turn that on and you need help with that, just get in contact with us and we'll help you. However, we don't use abbreviations in our letters as much as we should, in our descriptions of our files and our folders, but these are all in place so that you can follow the file system from start to finish all the way through. And if you look at that file system, you can see right now that's the project there right at the tip. There's the zone that it belongs to, and then down inside the zone is the welded member. It's a column. I can tell it's a column. And then down further I can see that there is a base plate connection, and there is a base plate connection because it says base and it says connections in the file name. This is how we can track where we are in the file structure really easily. So when we're looking at a file structure in a feature tree, we can go down the feature tree and we can look at the files and we can tell where we are. It's important that you understand where you are in your project when you're inserting items, because sometimes you might want to insert plates, fasteners and bolts into a connection because you might want to capture that connection and put it into your library. However, there's nothing stopping you from putting bolts, plates and fasteners at your welded member level. It means that if you wanted to capture them, you have to capture your welded member assembly and put that into your project, put that into your library. Now what that also means is if you go and put your plates, bolts and sections into your zone assembly, you have to take your zone assembly and add that to the library. That means everything in that zone assembly has to be put into the library. So where you put things in your project is very important. So the last file system, or the last file structure that I'm going to cover, is our SQL file structure. And the reason that I'm going to cover that is because it needs to be backed up. You need to back this up, and it needs to more than likely happen once or maybe twice a day. And a lot of people don't realize that their SQL database is just as important as the files in the file system. So I'm going to show you where the folder for the database is kept and for where the file is kept and what needs to be backed up. And then I might even give you an option of how to back this up. Okay, so if we go to our C program files, Microsoft SQL Server, you'll see here MS SQL 12.stp underscore through SQL Express. That's the folder for the database instance. And inside that, we go down into the tree structure and we come to the data folder. The data folder is usually kept away from those that are not administrators and they cannot get access or modify anything in there. So this folder needs to be backed up because this is where your database is installed. To back it up, you can have a syncing process to back it up so that free active sync can be used to back this database up, say to a Dropbox, to some online backup system. It is important that you continue to back this up on a regular basis and ensure that this gets backed up because our database is tightly linked to our files. There are database applications that you can download for free which will schedule backups for that. I think there's one that you can get online that will allow you to grab and install, and it will allow you scheduling backups. I think it's called SQL Backup, which is appropriately named. Good Sync will allow you to collect it. If we look down here, there's a SQL Backup Master. That's the one that I've used in the past, and I find that that one is free. Not sure if it's free now, but it used to be free, and you can set that up to back up your database and put it aside. Now, if anything unforeseen happens and you get stuck, say for instance your hard drive goes, which happens from time to time, you might lose your hard drive. At least this way you've got yourself backed up for your library, because I'm sure that you're going to have your library set up so that it's either in a Dropbox location or it's going to have a syncing application to allow you to back that up as well. And this combined will allow you to put it all onto a server. Now, if you get stuck, either any one of us at CAD Craftsman can help you to re-establish your project, your application after a disaster. So yeah, it's best that you back these things up. We've been there, and we want to make sure that what happens to you has never happened to us, where you may have lost project files and you've had to come back and redo them, and you may lose a day or two. So we don't want that happening. Okay, so I'm stressing the fact that you should back up these files on a regular basis. So let me say it again: your library and your database need to be backed up, including your project files and your project location. Now, those backup processes, if you want to know more about them, please contact us. We'd be happy to help you set them up. Okay. Last but not least, I want to thank you for sitting through this training session. I may have put you to sleep. I'm sorry if I've done that. I'm actually a master of hypnosis. No, truly I am. If you actually have fallen asleep, yeah, please watch this again. And yeah, thanks again for watching this. If you want to know more, or if you have any questions, please send a support question at support@cadcraftsman.com. We'd be happy to help you in any way, shape or form with your filing system and getting an understanding of how that works. Thanks for your time.